whatever. In the graph of f, determine whether dy dt is positive or negative. What the heck does that mean?
The rate of y.
The change of y with respect to time is positive or negative. I've got a graph. That's not feeling good for me, right? I double check my boundaries. This is a yx graph. That's really rude. There's no t on here. Feeling really nervous. But I'll keep reading. Or negative. Given that dx dt is negative, what does dx dt mean?
The change of x.
With respect to time. My change in x with respect to time is negative. What does that mean? Doesn't that mean my x is getting more negative? So which way am I running on my graph? So what does dy dt do?
It's going up.
So it becomes, there you go, done. That's it. That's it. That's all this problem is. Next question says B. It says determine whether dx dt is positive or negative given that dy dt is positive. So dy dt is positive. What must dx dt be? Negative, because I'm running uphill. Therefore, dx dt must be negative, because I must be running uphill. That's just weird. All right, everybody take a stab at 11. Reed's going to handle this one. Oh, go. Okay. Why? Whatever. Computers are very safe. They never break down or nothing. Your generation's crazy. Okay, so y equals ax plus b is my equation, a being my slope, b being my y-intercept. So far, good. I don't know why they didn't use m, because they're just being rebels. Whatever. If x changes at a constant rate, does y change at a constant rate? What? What do you got for me?
I think so. Because it says.
Explain.
Okay. So it says, so when x goes up one number, that's going to change the whole. Oh no, it's not going to be a constant rate. Wait.
I'll just keep staring at her. She can change her answer. Watch this.
Okay. Okay. I'm gonna go back. So
Okay, let's do some calculus, shall we? How do I find the rate of which y changes with respect to x?
So we're going to find the derivative.
I'm going to take the derivative, right? If I'm changing, so if I'm talking about the rate at which this changes, that's dy dt. Once I do that, I have to take the derivative of the other side, which is a dx dt. B falls off. So now I reread the question. It says if x changes at a constant rate. So in other words, this is changing at a constant rate, like 7. Then is this changing at a constant rate?
Yes.
Yeah, because it'd be 7a. Whatever this is, it's this times this does it. So as long as dx dt is constant, therefore dy dt has to be a constant. Does that make sense?
Yeah.
All right, fair enough. And then it says explain. I think this is explanation enough, although you might want to add some words to it. Make it pretty. Good?
Yeah.
Fair enough? Bottom you don't convinced. You're convinced. All right, flip it over. You're going to try problem number 15 if you haven't tried. All right, here we go. Mr. Hummer, the radius r of a circle is increasing at a rate of 3 centimeters per minute. Find the rate of change of the area when r equals 6 centimeters. Huh. All right, can I draw a picture?
Yeah.
All right, I got a circle, and the radius is changing at a rate of 3 centimeters per second. It's going out this way at 3 centimeters per second. Is that agreed? And I want to know when the radius is 6 centimeters.
Per minute.
What?
Per minute.
What's permanent?
Right.
Okay, fine. Good deal. Now, the question is, I want to find the rate at which the area is changing. Okay, so what do I know?
The radius is 6.
Radius is 6. I'm with you there.
And the rate is 3 centimeters.
The rate of what? How do I write that?
Rate of change.
Rate of change? How do we write that in mathematics? What's changing with respect to what?
What?
What's changing with respect to what?
Oh, time.
With respect to time. So you'd say it's the radius over time, but we're going to write dr dt, aren't we? Uh-huh. Is that okay?
Yeah.
And what's my dr dt?
3.
3 centimeters per second.
No.
Per minute? No way.
Yes. That's what I said before.
Minute? Really? Wow. All right. Oh, it's not a water problem. Okay, good. All right, good so far?
Yeah.
All right, what else you got? Anything else you know? That's it. What do you want to know?
You want to find the rate of change for the area.
Of area. So how do I write that?
A over dr dt.
I want to know the rate of change for area with respect to time, right? How fast the area changing.
Oh, okay.
So wouldn't that be the change in area divided by the change in time, would it not?
Yeah.
Does that make sense?
Yeah.
Okay. Pausing there. Everybody with us? All right. So now I need to find a formula that relates area and r of a circle.
Oh, pi r squared.
There you go. Area equals pi r squared. Since I'm trying to find area, circumference would be a really bad choice. All right. Now, how do I find the dAdt?
Well, let's make a dAdt
By doing what?
by multiplying it by dAdt.
No.
How
do you turn A into dAdt?
You just multiply it. It's 1 times dAdt.
Okay, you just did what we're asking you to do, but that's not what you're saying, right? You just don't multiply. If I multiply both sides by dAdt, I would get this.
No, but you don't multiply both sides by dAdt.
Okay, so what am I doing?
Oh,
I'm taking the derivative of both sides, correct? With respect to time. There you go. Now you got it. dAdt, and yes, there would be a 1 out in front, and that's equal to, throw the 2 out in front, I get 2 pi r,
and then
dr dt.
Yeah.
Then I just plunk the letters in where they go, right? dAdt is what I'm looking for. 2 pi, what's r?
6.
6, what's dr dt? 3, so I get that this thing's increasing at, area is increasing at 1836 pi centimeters squared per minute. Done.
Good thing we didn't do circumference.
That wouldn't have worked.
I said pi r squared.
Where'd you say you said circumference?
All right, get to work on the triangle problem, number 17. Well,